What if your city could predict a flood before it started, reroute traffic before the jam forms, or even flag a water pipe that's about to burst before it does? This isn't science fiction. It's called a digital twin, and it is already transforming cities around the world. My name is Precious Enongemi. Together with Edith B. and Zavanante, we break down what digital twins are, how they work, and how they can transform cities, including cities right here in Africa. Let's start with the problem, a very big one. By 2050, 68% of the world's population is expected to live in cities. That's about 7 billion people packed in urban areas, cities initially designed to host only a fraction of that number. Traffic congestion alone costs national economies over $1 trillion every year. 30% of urban water is lost to leaks before it reaches a tap, and 40% of carbon emissions come from urban buildings. The traditional response: we wait. We wait until the pipe bursts, then we fix it. We wait until the road floods, then we block it. We wait until power fails, then we restore it. This response is reactive, slow, and expensive. There has to be a better way. And indeed, there is a better way. That's the digital twin. But what exactly is a digital twin? Simply put, a digital twin is a virtual replica of a real physical system. It could be a building, a road network, or an entire city, which is continuously updated with real-time data. Think of it this way: the real city and the virtual city exist side by side. Sensors feed live information from the real world into the virtual model, and the virtual model in turn sends insights and decisions back to the real world, thus creating a continuous loop of improvement. Note, it is not a static map, it is not a blueprint, it is a living, breathing model that mirrors reality at every moment. The concept was introduced by Dr. Michael Greaves in 2002 and adopted by NASA in Spacecraft Lifecycle Management. But today, it has found its greatest application in modern city. There are three essential components of a digital twin: that's the physical world, which is the real city; the data connection that ensures communication between the physical world and the virtual model; and finally, the virtual model, that's the digital twin. A digital twin is not just one single technology, rather it is built from 6 layers. The physical layer, which represents the real world assets, that's buildings, roads, pipes, all equipped with sensors. We have the sensors and the IoT layer that represents that is the eye and ear of the digital twin. It includes traffic cameras, air monitors, and smart meters. We have the third layer, that's data thread, which ensures transmission of data in real time and includes 5G and fiber networks. We have the virtual model, that's the heart of the digital twin. It's the digital replica built using photogrammetry and LiDAR. Artificial intelligence and analytics, which are machine algorithms that detect anomalies and predict failures. And finally, we have the visualization layer, which consists of dashboards and AR interfaces for operators and citizens. The smart city uses technology to improve performance, sustainability, and quality of life across 5 domains. That's 1, smart mobility; 2, smart energy; 3, smart environment; 4, smart governance; and 5, smart infrastructure. The digital twin is the operating system connecting all 5. It is the platform that makes them talk to each other and work as one unified system. The technology stack behind a digital twin includes IoT for sensing, artificial intelligence for prediction and optimization, geography information systems for spatial organization, photogrammetry combined with LiDAR for 3D model creation, and cloud computing for scale. Of these, photogrammetry deserves special attention because without an accurate 3D model of the city, nothing else works. Photogrammetry turns photographs into precise 3D models, and here is how it works. A drone flies a programmed grid over the city, capturing thousands of overlapping photos, usually an 80% overlap between photos. Software finds common points across images and triangulates their exact 3D positions, creating thus a dense point cloud of millions of data points. These points are then stitched into a 3D mesh and photographic texture is draped over it. The result, a centimeter-accurate, photorealistic model of an entire city, scalable from a single block to an entire metropolis. This model thus becomes the foundation of the entire digital twin. Digital twins serve 9 major urban applications: 1. Urban planning, traffic management, flood and drainage, energy, waste collection or waste management, environmental monitoring, smart buildings, disaster response, and population growth modeling. Let's look at the most impactful ones. For traffic management, a digital twin simulates the effect of changing a signal before it is changed. It equally predicts congestion hours in advance, and studies across 6 cities documented up to 42.9% improvement in traffic flow in areas where digital twins technology was implemented. For urban planning, instead of showing residents a flat map, planners put them inside a photorealistic 3D model of a proposed development. Citizens can then see exactly how it looks from their street. This changes public consultation entirely. Environmentally, sensor networks map air pollution at neighborhood level. Flood models also give early warnings about water level rise. For energy, building twins optimize heating, cooling, and lighting automatically. Cities deploying digital twins have recorded 35% average reductions in energy losses. And for disasters, commanders get 3D situational awareness in real time, predicting flood extents and simulating evacuation routes. Emergency response times have improved by 44.9% in areas that implement digital technology. Now, let us look at real cities that have already built digital twins and what they achieved, including Singapore, Helsinki, Shanghai, and Dubai. Singapore launched Virtual Singapore in 2014 and is the world's first nationwide DVD digital twin. The entire city is modeled at a 0.5 meter resolution. Sensors cover environmental conditions, traffic, building energy, and drainage in real time. Government agencies, researchers, and private companies all work within the same platform. It is the international reference point for what national-scale digital twin integration can look like. Helsinki, on the other hand, took the open approach, releasing its 3D city model under an open license so that developers, researchers, and even students can use it freely. The result, Helsinki has achieved innovation that the city could never have created alone. Dubai went large-scale, created a high-resolution LiDAR and photogrammetry twin, which coordinates dozens of construction entities already designed for autonomous vehicles and advanced analytics. Now let's talk about Yaoundé. With a population of about 5 million, Yaoundé faces 3 simultaneous crises: seasonal flooding that overwhelms drainage and spreads disease, chronic traffic congestion, which is made worse by poor roads and transit truck routes, and a waste emergency where rubbish blocks the very drains that flooding then overwhelms. These problems feed each other, and most digital twin technology has been built for wealthy cities, but the need is greatest right here. But there is a pathway, a phased digital twin designed for Yaoundé specific constraints. Phase 1, UAV photogrammetry or drone photogrammetry builds a 3D terrain model, critical for flood flow modeling through the city's hilly landscape. Phase 2, sensors deployed at key points such as water gauges, traffic cameras, and waste field level monitors. Phase 3, a cloud artificial intelligence platform which predicts floods, congestion, and waste overflow before they happen. And phase 4, decision support tools for emergency managers, traffic controllers, and community leaders. 4. African cities can leapfrog, that Yaoundé can adopt proven frameworks without repeating decades of trial and error. And finally, the twin is not the goal. Safer, cleaner, more sustainable cities for real people. That is the goal. Thank you for watching. Hopefully this video helped you understand more about digital twins and smart city development. Feel free to drop your questions in the comments below.